Hello, Professor. This is Catalina, and I'm gonna go over this week's assignment.
Okay, so for this week, consists of two questions. The first one was a related sample problem. So this means that these scores were paired. So one score went like with the after score. The cases or the scores included in the sample were not selected independently from one another. So both were taken like from the same sample. So it was a within sample measure. So basically what we need to do here, now we're looking at differences. In the last assignment we were looking at the raw scores. Now we're going to look at differences. So what we need to know in the first problem is if driving ability is affected by a 0.05 alcohol blood level. So yeah, so first we need to calculate the differences. We need to find again a T obtained and compare it to a T critical like in the previous assignment, but like this time it is with differences, right? So our T obtained is going to be this equation over here, which is the mean of the differences minus, well, the population differences or mean differences divided the standard error of the differences. Okay, so first we establish our null hypothesis that this will be that this UDD is gonna equal 0, which means that there is a mean difference equal to 0 in driving performance before drinking and after drinking up to a 0.05 alcohol blood level. So yeah, the first step is always to calculate the differences. If we do this in a table, it is so much easier and faster. Then we calculate H difference minus the mean of the differences, and then we square this value. So here are all the values that we need to know. So I did the first problem, I did it in the positive direction, which was the after drinking value minus the before drinking value. Here I calculated the mean, which gives 1.6, and yeah, then the sum square deviations was 16.4. So first, to find the standard error, which is what you need to find the T critical, the T obtained, you need the standard deviation. So you need the standard deviation. Once we find the standard deviation with the sum squares used before, we can find the standard error. So we solve and we get a standard error of 0.427. Now we replace these values in the T obtained. So like I said before, this value is supposed to equal 0 in the null. So we can take it off and it will be the mean of the differences divided the standard error of the mean of the differences. And this will give a value of T obtained of positive 3.75. Remember that we made it in that direction. Okay, so for now T critical, because we need to find the degrees of freedom and our alpha level. So our alpha level is 0.05 and the degrees of freedom in this case is the sample minus 1, which is 10 minus 1, because it is a related sample problem. So by looking at the tables, we know our T critical is 2.262. So after having our values, we can reject the null at a 0.05 alpha confidence level because the T critical is smaller than the T obtained. So the T obtained exceeds the T critical. So the null is not true and it can be rejected. What does this mean? This means that the performance in driving ability before drinking and with an alcohol blood level of 0.05 does differ, and an alcohol blood level of 0.05 does have impact on driving ability. Now for the second one, it is a little bit different because they are independent samples. What does this mean? That they are no longer within subjects, but there are two different sample sets and the scores do not relate between one another. There are no pairs, there are no before and after score. There are two different samples, independent. So yeah, so the T obtained in this case is gonna be the mean of the first sample minus the mean of the second sample divided the standard error of both samples. So again, first the new hypothesis in this case will be cooperation has no effect on student friendship choices, which will mean that, well, as you can see here, this will be equal to 0. So as in the other part, first we start by filling out a table, which is easier. We fill out a table we calculate the mean of each sample, then each score minus mean, and then we square that in order to find the sum of square differences for both. Once we have the mean and then fill out this table, we can find the sum of square differences, and we can use that to find the variance for both. In this case, the variance was the same, and then we can use that variance to calculate the standard error, which is this huge formula. It's not that scary, don't worry. All we need is the variance, which we already calculated, and the sample size, which we have. So yeah, it looks big, but it's simple really. So we solve and we get that the standard error is 1.05. So now to find the t obtained, we just replace the two values found, all the values found before, and we divide. So the mean of the first one, the mean of the scores of the first one was 4. The mean of the scores of the second sample was 7, and we divide that by the standard error, which was 1.05, which will be -3, divided 1.05, which will be -2.86 approx. Yeah, so that's our t obtained. So now for t critical, here there's a little change. The change is that the degrees of freedom are no longer calculated n-1 because like we have two different samples independent. So we need to take sample 1 plus sample 2 minus 2 because there are two samples. So in this case, 10 plus 10 minus 2, which will be 18. And our alpha level again is 0.05. So we look at the table and we see that our critical value will be -2.01. -2.101, sorry. So yeah, a conclusion. After having all values, we can reject the null because the t critical is smaller than the t obtained. The t obtained exceeded the t critical. So what does this mean? Basically, this means, like in the problem terms, that cooperation does have an effect on student friendship choices. That was what the professor was testing. He wanted to see if cooperation had an effect on friendship choices, and he did that by comparing competition and cooperation, and we find out that it does have an effect because our null was that it doesn't have an effect, but like we rejected our null, so it does. And yeah,
have a good day, professor. See you next time. Bye.